sorry, GoA 2. Now we're getting into automation. GoA 2 is considered semi-automated train operation. Now, GoA 2 is now introducing your core rail automation functionality. This is where your core functionality for automation is introduced. The system is taking control of propulsion and braking. The system is supervising the speed and brakes the train if it exceeds these speeds. The system is determining its position on the track. The system transmits movement authorization data from the wayside to the train. So what you can see here is your core functionality for automation. These are your basic functions that are needed in order for the train to move on its own without a driver. So it's a very basic automated system. The system does not monitor station platform elements. And what you'll see is that when you move from GoA 2, 3, and 4, it is really the majority of the functions are related to adding more capabilities at the station in terms of monitoring the doors, closing the doors, et cetera. And we'll get into that in a little bit. But the point of GoA 2 here is that you're introducing your most basic automation functionality. Now, the driver is still involved and they still perform non-core, but they perform vital functions. They're in the front cab, they're monitoring, they're looking out the window. Even though the train is driving by itself, they're still observing the track to make sure there are no hazardous situations. For example, if there's a tunnel ventilation door that's usually closed in the case of a fire to provide proper pressure and whatnot, if that door is closed, it's the driver's responsibility to make sure they stops the train, because the automated train will not be aware of it in a GoA 2 system. So the driver is still performing a vital function in terms of making sure there's nothing in front of the train that could create a problem. The driver is also there to protect work crews that are working at track level. So an automated train may not be aware that there are work crews, but the driver is, in which case the driver will pull the train out of its automated mode and move in a manual mode while it's going through that particular part of track. Stop a train if a person has fallen on the track. So if you're at a platform and a passenger has fallen, the driver will be able to stop the train if possible. When the trains are at the platform at the platform, it's the driver's responsibility to ensure it's safe to open and close these doors. And finally, when the dwell has expired at the station, the driver determines if it's safe to leave a station and authorize the train to depart. Usually it's by pushing an ATO, button to allow that train to leave in automatic. And what it shows here is the system is taking care of the train in terms of moving automatically, but it is the driver that's still ensuring the safety of the system when it gets into the station platforms and also at track level under certain situations. Now, what I want to point out here is the jump from GoA 1 to GoA 2, it's an order of magnitude higher than the other grades in terms of complexity of the technology. When you're going from GoA 1 to GoA 2, you are introducing quite a few functions, complicated functions, in order to achieve automation. But when you move from GoA 2 to 3 and 3 to 4, the jumps are incremental. Once you accomplish the GoA 2, the complication of a GoA 2, going to GoA 3 is fairly straightforward. Doesn't mean that it's not any less complicated, but it's understood how you can incorporate that into your system. Whereas jumping from GoA 1 to GoA 2 is a significant jump, because you have to remember, in GoA 1, the driver observes the wayside or cab signaling. They're controlling propulsion and braking. They're basically taking the complicated function of correlating the wayside data into commands for the train. And that's a GoA 1 system. Whereas in GoA 2, it's taken all of that and automated it. And that is a level of complexity that is there's a significant jump when you go from GoA 1 to 2 versus 2 to 3 and 3 to 4. So you should be aware, just be aware of that point. Many people focus on GoA 3 and GoA 4, saying, oh, the level of complexity there to get to a GoA 4 is quite high. Sure, yes, it's a fully automated system, but GoA 2 is where the rubber meets the road in terms of introducing the core functionality. So in a GoA 2 system, it basically has everything from a GoA 1, but what's been added is drivetrain, which is this second function here, which allows the system to control acceleration and braking. Now, before I go into these functions, I have to circle back now to GoA 1. Many of the functions that we just talked about, ensure safe route, ensure safe separation of trains, and ensure safe speed, we need to revisit that in GoA 2 because it is implemented different from GoA 1. Once we've established the GoA 2 functions, going to GoA 3 and 4, these functions will not change. So I'm going to circle back now and explain for a GoA 2 system how all these functions operate. So circling back, ensure safe route. In GoA 1, when the conditions are met, such as is the switch in the right position, there are no trains in front of it, and other conditions, the aspect of the signal is set to red, green, or yellow. But in a GoA 2 system, if the conditions are met, such as switches in the right position, there are no trains in front of it, and other conditions, a movement authority is transmitted to the train from the wayside to the vehicle. And that's a difference between the GoA 1 and a GoA 2 system. We may still have trackside signals because the driver is there, but that's more a secondary mechanism. It is there for the driver to observe and possibly take action if needed, or if the system needs to drop into a manual mode, signals are there for the driver to allow to move the train based on based on the signal settings. But there's a difference between a GoA 1 and a GoA 2 when it comes to setting a route. Safe train separation. In GoA 1, we maintain a one block separation, which is 2 signals between trains, and that's considered the safety distance. But in a GoA 2 system, they'll maintain a minimum safety distance, which is not necessarily 1 block. It's basically what is the minimum distance the train behind must maintain with the train in front. What that means is under a worst case failure, the train will still stop without hitting the train in front. So that's not 1 block separation. This is not getting more into moving block, which the trains are keeping as close as possible between them. So between a GoA 1 and a GoA 2, this is the biggest difference. There is no 1 block separation, but there is a minimum safety distance. But if you have a non-reporting train or an unequipped train, in that case, then that 1 block separation rule would apply. But again, that's a secondary mechanism. So there's a difference when you're between GoA 1 and GoA 2 as it relates to safe train separation. Now, ensure safe speed. In a GoA 1 system, we talked about partial coverage of a speed supervision. The remainder was left to the driver to ensure the speed limits are respected, whether it's continuous or semi-continuous. But in a GoA 2 system, the system ensures speed is monitored at all times on all parts of the track. Basically, the speed profile, the designers will determine the speed profile for each part of that track on a straightaway, on a curve, uphill, downhill grade, and that'll be inputted into the system, and the vehicle will ensure that when it's on that section of track, it does not exceed the speed of that part of the track at all. And if it does, you apply brakes, whether it's emergency brakes or service brakes, whatever the system designers feel is appropriate. So that's ensure safe speed in a GoA 2 system, or the difference between GoA 1 and GoA 2. Now we get into the GoA 2 specific function. The first 3 functions I talked about were similar, were also applicable to GoA 1. Now this particular function is applicable to GoA 2 only, and that's control of the train's propulsion and braking systems. So the onboard system is now controlling your acceleration and braking. The train follows the speed profile of the track section. The train is able to stop at stations within a plus or minus 50 centimeter window or better if there are platform doors. So basically, the control of the propulsion system is under the control of the onboard controller, and the driver has no control over it unless it pulls the system out of this mode and takes control of the train. The onboard system is also responsible for ride comfort. The acceleration should be gradual, deceleration should be gradual. There shouldn't be too much jerk in the train where passengers are thrown around because the train is braking too hard. The ASC or the speed controller is designed such that the movements are gradual. So ride comfort and passenger comfort is taken into account. So now we're getting into the automation of the system and taking control of the train. And all this is based on the wayside transmitting the movement authority to the train. So an example of a GoA 2 system, I must be honest, I'm not aware of one I'm sure they're out there. And if someone is aware of one, I appreciate it if you would put it in the chat. But a GoA 2 system is basically the train is automated. It's able to propel itself. The propulsion is under control. Braking is under control. Movement authority is received by the wayside, but it's not monitoring any activity at the stations, which means if the doors open, the system is not aware of it. If there are work crews on the track, the system is not aware of it. If the tunnel vent doors are closed, the system is not aware of it. So it's basically just driving the train and nothing else. Usually, if you've achieved a GoA 2, the jump to GoA 3 is incremental, and most systems would make that jump to GoA 3. So I'm not aware of a GoA 2 system. If someone is, I'd appreciate it if they could type it in the chat. I'd like to know a GoA 2 system if it's out there.